Hi, this is Ms. Black, and this is Math 099 Open Campus, and we are now in Module 9, and we are moving to a new chapter. We will be talking about operations of rational expressions. So the first thing I need to know is we need to go over vocabulary. We need to know what the word rational expression means. The word rational has the word ratio in it, and a ratio means a comparison of two numbers. And when you compare two numbers, you're talking about a fraction. So if we said the number of boys to girls in the room was 10 to 15, that would be a fraction. That's what a rational expression is. Now, before we could do operations of rational expressions, which is our goal in this chapter, to add, subtract, multiply, and divide, we first have to go back to elementary school and review how to reduce or simplify a rational expression, which means to get it in lowest terms. So let's go to the board. Okay, so if you remember, back in elementary school, you had the fraction 10/15ths. And as you all know, we cannot accept that as a fraction because it's not in lowest terms. So we learn the fraction bar means to do the operation division. So we got to find a number both 10 and 15 can be divided by. So we have to know our multiplication facts. Okay, 10 and 15 can be divided by 5. So we're going to divide both the numerator by 5 and the denominator by 5. And 10 divided by 5 is 2. And 15 divided by 5 is 3. And we learned that if you write 10/15ths and I write 2/3, even though those fractions don't look the same, they are equivalent. They are equal. They may have the same value. That is just like in real life. If you have a dollar bill and you try to go get a Coke out of the machine and it won't take the dollar bill, you can exchange that dollar bill for 4 quarters. Even though a dollar bill and 4 quarters don't look alike, they are equal in value. They are equivalent. Now, if we go back to fraction world, I will prove to you that these are equal in value. I'm going to first draw a picture of 10/15ths. So I'm going to start with a whole thing, and this time I'm using a rectangle. I could use any shape. But it's easy to take a rectangle and divide it into 15 equal parts. And the way I'll do that is I'll make 3 rows and 5 columns. So if you look, there are 15 equal parts. The numerator 10 means I have 10 parts of those 15. So I will shade 10 of those parts in. That is a picture of 10/15ths. But it is also a picture of 2/3. Because 2/3 means I would take the same picture, break it into 3 equal parts, where if you look, there are 3 equal parts. There are 3 equal rows. 1 row, 2 rows, 3 rows. And out of those 3 rows, 2 should be shaded in, which they are. So that's the whole concept. When in elementary school we reduce a fraction, we are making something that it's equivalent to. When we reduce it, we're doing the operation of division. And when we divide, we have to divide the numerator and the denominator both by the same number. If you think about it, what is really 5 divided by 5? It's really 1. And dividing by 1 doesn't change your answer. So we're going to use this concept of arithmetic in algebra. Here is a fraction. Now we've seen fractions already in chapter 12. We just did not call them fractions. This division bar means we have a fraction, a numerator and a denominator. I want to divide. First thing, pet peeve, where does the negative symbol go? That's right. It rises to the top. Now we're going to divide. We're going to start with the coefficients. 12 and 8. What is the greatest number you could divide them by? Well, you could divide them by 2, but even bigger than that is 4. 4 divides into 12 3 times. 4 divides into 8 twice. Now we're going to divide our variables. And we learned in chapter 12, when you divide variables, what do you do with your exponents? That's right, you subtract them. So a squared divided by a to the first, 2 minus 1 would be 1, and we put the a in the numerator because that's where the bigger amount is. We took 1 away, it's gone. We take 1 away, We're left with 1. B divided by B. Well, that's b to the first divided by b to the first. Again, when we divide, we subtract the exponents. 1 minus 1 would be 0. B to the 0, we've already discussed this semester, means that there's an invisible 1 there. We don't need to write it. So all semester we've been doing, when you divide the same variable, it cancels out. The last is c to the first divided by c to the fifth. Well, when we divide, we subtract the exponents. 1 and 5, when you subtract, gets you 4. We put that in the denominator because that's where there were more. Take the 1 away, it's gone. 1 from 5 is 4. So this fraction that we are dividing or reducing, we are left with negative 3a in the numerator and 2c to the fourth in the denominator. So you've been reducing fractions all along. You've been working with rational expressions all along when we've been saying do division. Now, we're going to switch it up today. This was dividing monomials, and that's easy to do because monomials are connected by what operation? Multiplication. And if you remember your rules, please excuse my dear Aunt Sally. Multiplication, Mom, and division, Dad, are equal. So it doesn't matter which one you do first. If you recall, if I was a 5th grader and I asked you to work this expression, some of you would work it as 5 times 4, that's 20, and then you would divide by 5 and you would get 4. But that's not the only way to work that expression. We could do 5 divided by 5 and get 1, and 1 times 4 is still 4. So because multiplication and division are equal operations, it doesn't matter which one you perform first. But it's important that you understand you can only divide when you're connected by multiplication. If I wrote this expression, 5 plus 4 over 5, you couldn't divide first because this is not multiplication. You would have to add the 5 and the 4 and get 9, and then divide 9 by 5, and that would make the mixed number 1 4/5. If you tried to divide first, you would get the wrong answer. So if you tried to divide first and said 5 divided by 5 is 1, 1 plus 4 would not give you the 9/5. So it's very important in today's lesson that you understand. We're going to be talking about fractions. Fractions have the division bar. Division means you can only do it if you're connected by multiplication. Knowing that, let's step this up now. I don't want to just divide monomials, I want to divide binomials. Now, if you look in your notes, we're looking at our class notes, examples 5, 6, 7, and 8. So here's example 5, and here's example 6. Okay. Here's example 7, and here's example 8. Okay. If you notice, the first thing is these are not monomials. These are not connected by multiplication. They all have addition and subtraction signs. So the important thing that the lesson learned today is you cannot divide right now. You cannot come up here and just divide the letter X with the letter X and the number 6 with the number 6. You can't separate those terms because this is not multiplication. So how do we divide a binomial x plus 6 by a binomial x plus 6? What you have to do is you have to think of it this way. That @ sign is like a handcuff. These two terms are stuck together like glue. And the way you're going to remember that is to put them in parentheses. These two terms are stuck together like glue, like husband and wife. That @ sign means they stay together. I am asking you to divide all the numerator x plus 6 by all the denominator x plus 6. Now, what do you notice about them? They are the same binomial. Well, you know the answer to this then. If you divide the same number, for example, if I said divide 5 by 5, the answer would be 1. If we divide the same letter, A by A, the answer would be 1. So if you divide the exact same binomial, the answer is going to be 1. So you're crossing out the whole binomial, and you're saying I'm dividing the same thing, the answer is 1. So you have to learn to be able to recognize that these are the same binomial. Let's go over here. Example 6. I want to do division. First thing, to do division, I have to be connected by multiplication. That is not multiplication. That means these terms are stuck together. They cannot come apart. You can't just divide the numbers and then the letters. It doesn't work that way. So what you got to do is you got to say, okay, what do I know about x plus 6 and 6 plus x? Well, if you think back to algebra, you know your commutative property, which says it doesn't matter what order you add terms in. So we should all know 6 plus x really means, if we write it in descending order, x plus 6. And then if you look, x plus 6 and x plus 6 are the same binomial. When you divide the same binomial, what is always the answer? It is 1. Something divided by itself cancels out. Go to example 7. Totally different. This is x minus 6 and 6 minus x. First of all, again, what's the bar mean? Division. You say to yourself, okay, I can only do division when I'm connected by multiplication. This is not multiplication. Put parentheses. This is not multiplication. Put parentheses. So I can't separate the terms. I have to look and see if there's a relationship. Is x minus 6 and 6 minus x the same? No, they're not. That x is positive, but that x is negative. What do you call terms that are positive and negative? Oh, that's right. From chapter 12, they're additive inverses. They're opposites. Well, to be truly opposites, not only do the x's have to be opposites, the 6's have to be opposites. That 6 is negative, that 6 is positive. We have here additive inverses, which is a fancy way for saying we have opposites. We already know the answer to this. Let's go back to arithmetic. If I take two opposite numbers and divide them, what would our answer be? What is negative 5 divided by positive 5? It's negative 1. What is negative 8 divided by positive 8? It is negative 1. What is a positive 3 divided by a negative 3? It is negative 1. So we have a rule. When you divide opposites, additive inverses, your answer is going to be negative 1. In algebra, you have got to recognize that these binomials are additive inverses, and when you divide them out, the answer would be negative 1. So you're looking for patterns. Our last example, 8, if you look at it, again, we're dividing. In order to divide, what do you have to be connected by? Multiplication. Okay, that is not multiplication, so I put it in parentheses to let myself know it's stuck together. This is not multiplication. I put it in parentheses to let myself know it's stuck together. So now we look. Is saying x plus 6 and x minus 6 exactly alike? No. Adding 6 to something and subtracting 6 to something is not going to be alike. So these are not the same binomial. So the next question is, are they additive inverses, opposites? Well, the numbers are opposites. 1 6 is positive, 1 6 is negative. But the letters are not. These variables are both positive x. And to be an additive inverse, everybody has to be opposite. And it's not. If the variables are not opposites, then this is not an additive inverse. So we have a problem. These are not the same binomial. They're not the same. And they're not additive inverses. So then what are they? Well, if you go back to chapter 12, we learned a vocabulary word. When you have a binomial and you change the middle symbol only, a binomial and you change the middle symbol, these are called conjugates. And you need to learn you can't reduce conjugates. You can't divide them. This is in lowest terms. As you all know, some fractions cannot be reduced. If I said reduce 1/3, you couldn't do it. That's as low as it goes. So some fractions in algebra cannot be reduced. This is the final answer. It's in lowest terms. So what you need to do is you need to work on facts. You need to understand dividing the same terms, whether monomials, binomials, or trinomials, will always give you a 1. Dividing terms that are additive inverses, truly opposite of each other, the answer will always be -1. And if you divide conjugates, well, you can't reduce that. That is in lowest terms. That's as low as your fraction can go. Okay, now we're going to use this fact to actually do some more complicated problems. If you look at your class notes quickly, we're going to go look at example 10. Example 10 has 3y minus 3 over y squared minus 2y plus 1. It's a rational expression. It's a fraction. It has a fraction bar. What does a fraction need to do? It means to do division. But wait, in order to do division, you have to be connected by multiplication. This is not multiplication. Those terms are stuck together. This is not multiplication. There's subtract and add. These terms are stuck together. Now, you're going to say to me, well, look, they're not alike, and they're not additive inverses, and they're not conjugates. You are correct. But this is the important thing. We're going to learn how to reduce an algebraic fraction, a rational expression. I have a little song I wrote to help you remember what to do. It goes, reducing fractions, so much fun. Factor cancel, then you're done. We are going to learn how to reduce this by using our factoring skills. Because if you remember in chapter 13, factoring means make multiplication. We can factor this and make it connected by multiplication. And as long as it's connected by multiplication, then you can do division. So what rule of factoring are we going to use for 3y minus 3? Yep, that's right. We're going to use GCF. What is their greatest common factor? It's a 3. What's left when you divide by 3? 3y divided by 3 is y. Negative 3 divided by 3 is -1. Now you've made multiplication. We're going to factor the denominator. That's not the GCF rule. That's got 1, 2, 3 terms. That's your trinomial rule. So if you remember, we're going to put 2 parentheses. We're going to ask what multiplies to the first term. That'll be y times y. We're going to ask what multiplies to the last term, 1, and we'll also add to 2. That'll be 1 and 1. 1 times 1 is 1. 1 and 1 will add to 2. Because I want to add to -2, symbols both have to be negative. So we factor. So the first step to reduce an algebraic fraction is to factor. Once you got it connected by multiplication, now this is the fun part. You can cancel. If you have something the same in the numerator and the denominator, it will divide out. If you look, the numerator's got a y minus 1. The denominator's got a y minus 1. We cancel it out. And now our fraction is reduced. What's left in the numerator is a 3. What's left in the denominator is a y minus 1. You just reduced, got a fraction into lowest terms in algebra. Okay, let's try one more. Let's look at our class notes at example 13. Okay, you have 16 minus a squared over 2a minus 8. So here's the important thing. The directions are no help in algebra. They just say simplify or reduce. You have to understand what you're doing. You have to be able to look at this and say, I have a rational expression, a fraction. Fractions always mean division, because that's what that bar means. I cannot divide unless I am connected by multiplication. This is not multiplication, so it stays together. This is not multiplication, so it stays together. But wait a minute. I've learned how to make multiplication in algebra. That's factoring. So, reducing fractions, so much fun. Factor cancel, then you're done. That's your steps. You factor first, then you can divide, cancel. So what rule of factoring are we going to use here? Oh, that's a difference of perfect squares, DPS. So we put 2 parentheses. What times itself is 16? 4. What times itself is a squared? A. What are our signs? plus and minus. How do we factor the denominator? That's our GCF rule. What do they have in common? We can divide them by 2. What's going to be left when we divide? 2a divided by 2 is a. Negative 8 divided by 2 is negative 4. That's the factoring step. Now that you've made multiplication, now here's the fun part. Something in the top, the numerator, and in the bottom denominator should cancel, should divide. So first you look to see if you have anything that's identical, the same. Well, you don't. 4 plus a is not the same as a minus 4, and 4 minus a is not the same as a minus 4. That 4 is positive, that 4 is negative. That's not the same. But wait a minute. They are opposites. Positive 4, negative 4. Negative a, positive a. So these expressions here, you've got to recognize are additive inverses. They're opposites. And you could divide opposites and it would make a negative 1. Now, where do you put the negative 1? Would you put it in the denominator? No way. We never put a negative in the denominator. So we're going to put the negative 1 in the numerator, and it's still connected by multiplication. So now when we write our final answer, we have in the numerator 4 plus a times negative 1, and we have in the denominator a 2. That is unacceptable because you got to use your multiplication skills and multiply this. And remember, to multiply a number to a parentheses, you use your distributive property. So 4 times negative 1 is negative 4. A times negative 1 is negative a, and it's over 2. And that is your fraction, your rational expression reduced. So to sum up what we learned today, we learned that algebraic fractions are just like arithmetic fractions. They mean to do division. But to do division, you must be connected by multiplication. Therefore, you need to use your factoring to make sure all the fractions are connected by multiplication before you can reduce them. Have a great day.